Just the facts. No hype. I am Mark Sponsor, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, June 15th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Happy Father's Day. If you enjoyed the video, please give us a thumbs up. If you haven't subscribed, please click the Stormsurf icon down in the lower right-hand corner of the screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Our Predicament, Ashwin Sodhi, Peter Carpenter, Tim Caston, Elliot Harris, Clay Goose, and our big contributor for the week, Coach Nate. Thank you all so much. I hope you have a great week, and I do really appreciate your donations. With that, let's get to work. We'll start by looking at significant wave heights around the planet. North Pacific, not a whole lot going on. No, that is not unusual given the time of year. South Pacific, notice the ice anomaly trying to break up here. That's good news. I hope it breaks up sooner rather than later, and you'll see why in a minute. A little bit of energy in the 20-foot range scattered around, but nothing really significant in terms of producing swell relative to our forecast area. North Atlantic, pretty quiet as well. South Atlantic, gale with 21-foot seas trying to push south of South Africa. But the real focus here is the Indian Ocean. Again, multiple systems here with seas 30 feet, 28 feet sort of thing. Let's see, 35.6 feet at about... That's probably that one right there. You see the coordinates here. So these are the highest seas over the entire image and over the for all the significant wave height models, and then for the bigger oceans, that feature is incorporated on the chart down here somewhere. So for right now, another one little thing to consider: the low pressure bias. Probably somewhere right around here. That's part of the El Nino, and not El Nino, but the ENSO discussion right here. So it is no big surprise that the majority of action is somewhere in the vicinity of that low pressure bias. The hope is that that will move into the Pacific as we get over the next 2 months or so. So that's something to look forward to. All right, let's go take a look at current conditions. We're going to do that by, of course, checking the buoys. We're going to start up north off of the Oregon-Washington border, the Grays Harbor buoy, number 036. We're looking at all the energy that's hitting that buoy all the way up from 33.3 second period energy. That'd be really fast-moving swells, 0.0 feet. The whole way down the chart bottoms out at 5 seconds. That's pure, for the most part, unrideable wind swell. We see just these little micro bumps of energy at 20 seconds, another one at 13 seconds, but primarily wind swell, 0.8 of a foot. Let's go see how the algorithm does at putting it all together. Primary swell 1.5 feet at 8.4 seconds from 295 degrees. That would make surf at 1.2 feet at a standard beach break, no swell enhancing bathymetry or reefs or channels or anything like that. And then secondary swell 0.7 of a foot from 13.4 seconds from 232 degrees. And that would put surf at a foot, which would be, knee high. So things pretty quiet in the Pacific Northwest. Let's head south. We go down to Point Reyes Buoy, 029, just north there of the San Francisco Ocean Beach area. Now we see a little bit better profile here. Wind swell, peak energy, 7.7 seconds, 2.8 feet of energy, but you got to add in all this stuff on the shoulder too. But then our southern hemiswell, 1.3 feet at 16.7 seconds and 18.2 seconds, plus the energy on the shoulders. Now, this is from a rather steep direction. I was in the water this morning at a rather protected south-facing break, and there wasn't a whole lot going on. But if you went out to more exposed breaks, there for sure would be more wind swell, but there would also be more southern hemiswell. Anyway, primary swell, 5.4 feet at 7.7 seconds from 325 degrees. That would put the surf height at about 4 feet, so let's say chest high. And then that secondary swell, 2 feet, 17.2 seconds. This says 177 degrees. I think, the buoy, when you got competing swells coming from basically opposite directions, it's not going to be super accurate on the heading. Anyway, surf, 3.5 feet. Certainly wasn't that big where I was, but I'm sure it was somewhere. Then down to Southern California, the Point Loma South buoy, 191 off of roughly San Diego, California. There you go. Wind swell blocked by the Channel Islands. Southern hemi swell completely exposed, looking rather solid. We'll just take a look here. Primary swell, 2.8 feet, 1.1 seconds from 190 degrees. That would put surf at 4.5 feet. Then your wind swell in the background there, 2.4 feet at about 8 seconds from the west. Knee-high surf, something like that. Southern hemi, for sure. Southern California, that's the place to be. I saw one reading, was it yesterday? I think it was, like mid-afternoon, 4 feet at 20 seconds. It was either yesterday or the day before. I mean, that was just one reading, mind you. Probably one stray wave embedded in one stray larger than normal set. But 4 feet at 20 seconds is, something that gets your eye real quick. Unfortunately, it's not like that now. But still, there's definitely good surf at exposed breaks in Southern California. And we head over to the south shore of the Hawaiian Islands, Little Lanai buoy, 239, good proxy for everything that's going on there. Most of this energy, the storm that's producing the swell that is hitting right now in California, was in the far southeast Pacific, totally bypassing Hawaii. So background energy, you see roughly half a foot in between the 13 and the 16 second period band. See how the algorithm does. 1.1 feet at 13.7 secs from 192 degrees. That's 1.5 foot surf. And then 0.6 feet, the secondary swell at 17 seconds from 186 degrees. And that makes surf at 1 foot. So, I don't know, thigh high maybe if you throw it all together and get lucky on some of the bigger sets. So let's do the tour and see what has been happening around the planet, sort of a close-in inspection. We're going back over the past week. Last week's video on the 8th of June, 18Z. That was the last run of the model. We're just going to see what has happened every 6 hours for the past week in the North Pacific. And the expectation is not a whole lot. You see some sort of a tropical system. This was on Wednesday, but it didn't really do anything. And then here we are Friday, Saturday, Sunday, another little tropical system today, trying to organize somewhere south of Cabo San Lucas. Here's the current model run. It's kind of dissipating. No real swell except for maybe Cabo expected. Certainly not up in California. And as expected, North Pacific, pretty quiet. The interesting part is, though, there is still activity, okay? That speaks to we're still in some sort of a springtime pattern, right? And if you're at all familiar with what's been going on with the northwest winds along the coast north of Point Conception, it's just been a steady wind machine. Again, that speaks to we're not really in summer yet. We're in some sort of a late spring pattern. I typically say summer starts on the 4th of July, at least in Northern California. Maybe things are a little bit different for your area, but something to consider. So now we go to the southern hemi, South Pacific Ocean. A little gale developed on Friday, the 6th of June, going back a little bit further in we'll call it the central South Pacific. Notice the ice anomaly there. And it started building pretty rapidly with 38-foot seas. This was on the 187-degree path up into Northern California and 189-degree path, I think it was, if you literally drew the Great Circle path. And 189 into, Dana Point area sort of thing. And then the gale continued into Saturday and Sunday, finally wound down. San Diego about 118 west. So this is right on the edge of the San Diego swell window before it finally faded out on later Sunday a week ago. Now here we are, the current pattern. Notice the ice anomaly bumped up again. We'll go back, look at that. It went from there to what the heck? How did that happen? And I'm still not sure exactly how. And then it corrected itself and went back down. There we are. So this is real. Notice it got smaller again. I think there are some unexplained things in how the data is collected. You see it kind of building and pulsing there a little bit. And now here we are, Sunday, current run of the model. This updates, I think it's either at 12, I think it might be at 06Z each day. So it's slowly decaying away. The hope is it decays quicker. That will provide us more room here. So if storms take the southerly track through the South Pacific, they will actually the wind will get traction on the ocean surfaces. There's big chunks of ice there. It's going to do nothing for helping us produce swell. And you'll see as we get into the forecast, this is going to make a bit of a impression or have an influence on the forecast moving forward. All right, so that's current situation. Not a whole lot going on at the moment. North Atlantic, another hint of the spring isn't completely over yet. More low pressure pushing off the northeast coast. Forecast building, or this actually did build. This is not a forecast. This is actuals. On June 10th, Tuesday, seas were 27.7 feet, going up to 28 feet. Swell from that pushed into the European area on Thursday, the 12th of June, faded out. Here we are into Saturday, and now Sunday, the 15th of June, another little low pushing off the U.S. East Coast. Then we go to the South Atlantic. We're reviewing again what's happened over the past week. Pretty quiet pattern. See a little gale did blow up here along the southeast coast of Africa with like 20-plus foot seas. Another one developed 28-foot seas on Thursday, the 12th of June. And another gale developed here about midway between South America and Africa with 20, 22, 24, 26, maybe 27-foot seas. And continuing on into Saturday with 28-foot seas, you can see swell pushing towards South Africa on, pretty much today, if not starting to impact it right as we speak. So some swell for that area. And then finally, the Indian Ocean a week ago. Nice little gale developed with 36.9-foot seas pushing off to the east. You can see the swell hit Australia, pushed up into the Bali area or Indonesia. Then we had another system with 38-foot seas. Did it get higher than that? 39-foot seas pushing south of southwestern Australia. Notice a little bit of an ice anomaly developing there as well. So here we are about 24 hours ago. You can see swell pushing into western and southern Australia. Another little gale here trying to organize, but it's falling south. Probably, in current time, here we are. Yet another one in the central Indian Ocean. Hopefully it will build. We'll find out in just a minute. So what is to come? This is going to be the deep dive for the South Pacific Ocean. We're going to start by looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a push in the jet to the north, and there's a weak little trough there. If it was deeper, it would help support a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure in the southern hemisphere. And of course, low pressure, if it's strong enough, generates winds that impart energy to the ocean, that generate seas. As those seas eventually radiate away from the fetch area, the weaker elements of those seas, the lesser period elements decay off, exposing the longer period swell energy. And of course, swell, when it hits your beach, creates surf. All right, so we have a very split jet stream flow here over the West Pacific. That typically supports high pressure in the middle, does nothing for really promoting storm production. Now, the jet finally consolidates in the far southeast Pacific, but again, it is this southern branch of the jet stream that really is the main focus or supporter of storm production. At the current moment, nothing is happening. Let's put this into motion. So we get into Monday, a little bit of a trough tries to set up over the southeast of New Zealand. I mean, winds are only 110, maybe 120 knots. That's just bare minimum enough. Another little trough on Tuesday in the same area, but not a lot of wind going on. Now, notice here in the northern branch of the jet, there actually is a fair amount of winds, 170, maybe even pushing 180 knots. And that maybe will get what I'd call a cutoff low set up here. The main flow is down here, but at this point of the game, just looking, there we go. That looks pretty nice, actually, as we get into Wednesday, the 18th of June. And then that trough fades out, starts falling south. And again, this very split pattern in the west, consolidated pattern in the east, but falling south, just nothing super supportive of gale development. Now we go out, we're almost out a week out. It looks like there's almost some sort of a trough trying to set up in this area. Nothing great. 180 hours out, there's maybe something, but the ice line is like at 65 south. So even if a gale did develop, most of it would be over Antarctic ice, is about the area for the Ross Ice Shelf here. So nothing looking particularly great in the models, at least at the upper level. Let's go down to the surface. Here we are, surface level pressure, surface level winds, barely a gale, a tiny area, 35 knot winds. You got to have 35 knots to be classified as a gale, and I believe it's 50 knots for a storm. That's 50 knots or greater. We're nowhere near that. Basically, this is about as placid a pattern as you get. Notice a little gale, storm, little tiny area, 50 knot winds here tonight, but it's falling south. The fetch has to be aimed off to the northeast to get up into California and Hawaii. Now, here is a legitimate gale on Monday. Let's see, 35, 40, 45 knot winds over a small area, pushing east, building, almost lifting a little bit to the northeast. The ice line, 65 south, so it's exposed. The anomaly is somewhere over here. So we'll have to see how that plays out. But this looks like it will get exposure. Potential for generating swell. Also notice, I'm going to go back a day or two here, where that trough is in the upper reaches of the central South Pacific. We end up with a gale with 35. I'll pull this away for a second there. 40 knot winds. Yep. Building to 45. There you go. Aim due north. I mean, relative to Hawaii and Tahiti, it looks promising. We're Wednesday, the 18th of June. Still a good size fetch of 40 knot winds aimed due to the north. Hawaii's at 158, something like that. Oahu, it's up, off the end of the chart here. But this fetch aimed directly at the Hawaiian Islands and continuing into almost Thursday before it starts petering out. After that, things settle down. Let's see. Notice this 55 knot winds in the deep southeast Pacific. The ice line, somewhere around here. Maybe surf for South America, Chile, Peru area. It'd be almost a direct southerly hit if that happens. And then let's take it on out. Another fetch starts building here almost a week out, Sunday the 22nd, with 35, 40, 45 to almost 50 knot winds sweeping off to the east. Again, the ice anomaly, who knows what that's going to do, but that looks like a legitimate gale. Now notice, there wasn't a whole lot in the jet stream that indicated it. When that happens, I kind of wonder if the surface layer in the models is overhyping what's going on. You really want good upper level support. But for right now, given where we're at, there's really nothing on the charts too dynamic or interesting. So any little thing, and again, it's a week out too, but any little thing gives us reason for hope. So what effect are those winds going to have on the ocean surface? Well, here we go. This is the wave model, the ice anomaly. Now note, the wave model does not account for dissipation of ice or anything or the effect of winds on the ice. It just goes, here's what the configuration of the ice is right at this moment in time. And then it just like locks it in place as if it's land for the entire duration of the model. But you and I know that over time, this ice, at least theoretically, should be breaking up. All right, so we'll put this into motion. I say that because here is a gale with 33-foot seas. There's the anomaly there. This is on, we'll say, Tuesday morning. Still 33-foot seas, free and clear of the ice into about midday Tuesday. And then clearly it looks like the ice is doing something to like interrupt the swell production of the gale. But there is some hope there. Now, we also, as we get into Wednesday, we're going to look at the cutoff gale, and here we go. That is barely 30-foot seas. We'll call it 29-foot seas, aimed due north directly at Oahu and Kauai, and then it sort of fades off. It looked bigger and better maybe 2 days ago, but it's still on the charts. And just given its northward position, that's much less distance it has to travel to get to the Hawaiian Islands. And, of course, Tahiti, I think it said somewhere around 140 and 20, so somewhere right in here. Should see some energy from that. I'm not super optimistic about California's chance for swell because all the fetch was aimed due north, not northeast at the U.S. West Coast. So, but oh, look at that, a little bit of regeneration. That is the tiniest area, 30-foot seas. It's like throwing a pebble into a pond really hard and hoping you're going to get some big ripples out of it. Probably not a whole lot, but who knows? We'll see. And that's like 5 days out. All right, continuing out. Then we have another one of these gales. Almost a week out, 31-foot seas, slamming right into the ice anomaly. A week from now, I would expect this thing to be significantly diminished, but my expectations in reality are not always one and the same. So we'll just have to keep our eyes on that. And that's the week out forecast. I don't believe anything, even a week out on the model, much less models that go out 2 weeks. It's just a big tease, not even worth looking at. All right, let's continue our tour of planet Earth and wave or sea height forecasts. We're looking anywhere there might be surf. So we're in the North Pacific. We'll just put this into motion. We're looking for any seas higher than 20 feet, which would be that magic kind of orangish flesh color. Probably aren't going to see it given that we're pretty deep into June now. We're into Friday, Saturday, the 21st of June, and almost a week out. There we go, 180 hours out. Nothing going on. No surf expected from the North Pacific. To the North Atlantic, I wrote this off weeks ago, and it keeps teasing us and producing something. There you go. Tiny little area, 20-foot seas, aimed at Europe. Pretty good long distance away. I don't know that really any swell would result from that. But it's still at least trying to not give up the ghost, if you will. And there we are, 180. What's this? Is this actually some sort of, yeah, my guess is that's a result of some sort of tropical activity. Now, the GFS model that's driving all this regarding tropical systems going out a week, total fantasy land. Don't believe it's going to happen. Water temperatures, especially down here in the main development region, not good. Trade winds, not good. Not a great environment for tropical development, but who knows? Maybe the model will make a liar out of me. The South Atlantic. Put the models into motion here. We see activity pushing into the Indian Ocean, but we're really trying to focus on Africa. There we go. 27-foot seas aimed well up the coast here. I mean, that would produce swell, just raking up the southeast coast, building to 30 to 31 feet, and then starting to move out. Another one behind that on like Wednesday into Thursday, the 19th of June. Smaller. Again, they all seem to be really local sort of storms lately. I don't know if that's normal. I'm not a super long-term follower of the South African weather patterns, but seems they're a bit further north than normal. We're into Sunday now. Another system, broader system, building 20, 30-foot seas. Again, the same thing. Oh, and right up the coast is 180 hours out. Again, the same caveat about, yeah, I don't believe the model. But all in all, South Africa looking to get some activity. One last stop, the Indian Ocean. All right, so let's see what is forecast here. A little tiny gale, 32-ish foot seas. Another area of seas interfering or getting interfered with by the ice anomaly there. Not a whole lot happens. Then we have that other system, one of many, pushing off of Africa, South Africa, seas building to 32 feet, but falling southeast. You really want it to be pushing off to the northeast optimally. Now, here you go. You see some activity here. That's 20, 22, 24-foot seas. That's good for 14-second period. And that could result in swell pushing up into Indonesia and Western Australia. Here we go. Oops, and that was 180 hours out right there. So no big barn buster storms indicated, but not a completely quiet pattern either. Local wind forecast for California, Hawaii. California here, Hawaii out here. That would be Southern California there, Point Conception. Central California, there's San Francisco. And Cape Mendocino up there, the Hawaiian Islands here. Generalized high pressure pattern here, producing those isobars from the high, pushing into the coast, heat low inland, tightens up the isobars, creates a gradient, making pushing the isobars closer together. That generates winds. So 20 to 25 knot winds over Northern California, 20 knot winds. This is Sunday today, and trades 15 knots for the Hawaiian Islands. So we get into Monday, pretty much the same pattern, this gradient going the whole way down over the Channel Islands. Southern California, well protected from the wind swell. California, for the most part, north of Point Conception, pretty lumpy and bumpy and not beautiful. Notice a good fetch of 15-knot trades of pushing over the Hawaiian Islands. Maybe good for some wind swell into the Hawaiian Islands on Monday. Tuesday, some variation on the same thing, but up in north of San Francisco, the gradient loosens up, low pressure building in the Gulf of Alaska. Wednesday, the gradient returns, nosing in under the low pressure. 20, 25 knot northwest winds again, trades 15 knots for the Hawaiian Islands. Thursday, same deal, it just doesn't stop. And this is like a typical spring pattern. You get upwelling, colder water temperatures, all that kind of stuff. I mean, that's exactly what this looks like. And it seems like it's a later spring pattern. And this wind didn't really start developing till mid-May or something. I mean, and then it started getting real. So it's been really consistent May into now June, at least the past 4 to maybe 6 weeks, something like that. I mean, you can correct me if I'm wrong. And then trades, there you go. There's your high pressure as clearly defined as it could be. As long as there is low pressure pushing through the Gulf of Alaska, it's going to shunt that high further south, and then that's going to bring the winds down into the central California coast. If you didn't have low pressure up here, the high would be displaced to the north. The gradient would be more focused in this area, meaning less wind and less upwelling for central California. Hey, we're Friday. We're going into Saturday the 21st, and it's just repeat, same thing. Winds, if not 30 knots, as we get into a week from now, and then continuing. No real change for the next week. I mean, great for wind swell, not great for any southern hemiswell, but, you know, after like today, after tomorrow, I'd say, I don't think we have to worry a whole lot about southern hemiswell into California, so at least there'll be wind swell if you want to surf. Temperature forecast for the intersection of the Pacific Crest Trail and Tioga Pass Road there in Yosemite Valley. The elevation where the two intersect, about 8,700 feet. So if you're hiking the PCT or the John Muir Trail. Now, this hasn't updated since Thursday, but really not a whole lot's changed. A pretty mild pattern. Temperatures, 45 at night, 55 during the day. Maybe getting a little bit warmer Tuesday and Wednesday this coming week. 55, maybe 60 degrees, and then cooling off some after that. So a reasonably decent hiking temperature forecast. All right, so let's go check the actual surf forecast for a couple locations down the coast. Just like the buoys, we'll start up north, Columbia River area there at the border between Oregon and Washington. Sea heights or surf heights, 3.8 feet maybe on Monday afternoon. Maybe 5 feet on Thursday. This is all probably more than likely just wind swell generated into the 3.5 foot range for next weekend. Winds, not too horrible. I mean, blowing at times, but not too bad. Let's go take a look at the swell forecast. 3.8 feet at 10 seconds on late Monday into Tuesday. 4.5 feet at 11 seconds on Thursday, Friday, Saturday. 4.5 feet at 8 seconds. So all just basically westerly wind swell. Going down to Ocean Beach, San Francisco, surf heights 3 feet, fading to 2 feet or less, about 2 feet as we get into Thursday, and then 1.5 feet into next weekend. Wind speeds, this is not like right at Ocean Beach, probably about 5-10 miles off the coast, northwest, 25, 20, 30, 30. Pretty much exactly what we saw in the wind model before. Surf heights, well, we have southern hemiswell in the water as we get into Monday. 2 feet at 15 seconds. That's probably the last day of any real surf. Tuesday, 1.8 at 14 seconds. You see it fading down. Maybe another little background pulse of something, 1.5 feet at 13 seconds on Thursday and Friday, and then 1 foot at 16 seconds on Sunday. So really just background swell, nothing. Look at the height, surf heights. Yeah, 2 feet, really. Nothing particularly meaningful. Dana Point, California, Southern California, surf heights. Yeah, swell hitting right now, 4 foot. As we get into Monday, that starts dropping off. And by the time you get into Wednesday, Thursday, not a whole lot, maybe a little bump, 2 foot surf next weekend sort of thing. Wind speeds, your typical afternoon winds, nothing meaningful there. Let's take a look. Monday, 2.2 feet at 15 seconds early, fading from there, and then it all just descends into wind swell. It doesn't even pick up any of the other southern hemiswell. But I know that it will be there because you saw it up in San Francisco. But again, whatever swell there's going to be, I would call it waist high or less. South shore of Oahu, 2.5 foot surf going into Monday. Steadily fading, maybe bumping up a little bit on Thursday. We're talking 2 feet, 1.5 feet. Good for long boards, logs on the South Shore. Trades 15 to 20 knots, maybe a little bit lighter next Saturday, but not a whole lot lighter. Here we go. Swell heights, 1.7 feet at 14 seconds on Monday. 1.5 feet at best at 12 seconds on Tuesday. Fading from there, another little pulse of energy, maybe 1.5 feet at 15 seconds on Thursday. You can sort of read the chart for yourself, and then the period just steadily drops from there. So no immediate big swell. I mean, that really is the call right now. It is, we're waiting for something to get going in the South Pacific to generate swell. Otherwise, it's just all background energy. And then one final stop just to tease those of us in the Pacific. Bali, of course. Surf height 7 feet today, going up to 9 feet on Tuesday, fading down, then up to 12 feet on Friday, Saturday. And you see the pattern here. Trades in the 15 knot range pretty much the whole way through the period. Swell heights 5 feet at 14 seconds. We get into Tuesday, 5 feet at 16 seconds. Fading on Wednesday as period drops into 12 seconds, then back up to 7.8 feet at 15 seconds. Later Friday into Saturday, and then another pulse at 6.6 feet at 16 seconds. So no shortage of surf for the Indian Ocean. All right, let's go take a look long term. We're going to examine the two major weather oscillations that affect the potential for storm and therefore swell development in the Pacific, or, pretty much the Pacific Ocean. Those are the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We're first going to discuss the MJO, the Madden-Julian Oscillation. There are two phases to it, the active and inactive phase. They both rotate around the planet from west to east on the equator. Active phase on one side of the planet, inactive phase on the other. There's their rotation around the planet, if you can imagine that. The active phase is effectively a low-pressure system. When it moves into the West Pacific Ocean, it takes warm, moist air down at the ocean surface, lifts it aloft, that gets lofted up into the jet stream. It feeds energy to the jet stream, making the jet stream stronger, making it more capable of supporting troughs, and therefore low pressure development. It also, because trades are generated by high pressure, if the active phase is moving across the Pacific and it's low pressure, it actually reduces trade winds by cutting the pressure in the highs that generate the trades. So, and that can be a good thing. It helps transport warm water from the tropical West Pacific to the East Pacific. The opposite phase of that is the inactive phase of the MJO. It is like a high pressure system. It cuts off the flow of warm, moist air aloft. The jet stream gets weak. It splits, just like what we're seeing in the South Pacific Ocean. It is not good, therefore, to support gale development. And if anything, the trades start building because The inactive phase is a high pressure system that couples with the high pressure systems north and south of the equator that generate the trades, and it basically feeds them. And so that's not, so basically the active phase is our friend. It's low pressure. The inactive phase, not our friend. When they're in the Pacific, they take about 4 to 5 weeks to make their journey across the Pacific. All right, so what are we looking at here? This is an indicator of trade winds. This is data from the TAO buoy array, a series of buoys strung across the equator in the Pacific. This is the far East Pacific. This is the West Pacific. That's New Guinea there. 0 is the equator. 180 is the international date line. We're just looking at the arrows. The longer the arrow, the stronger the winds. These are 5-day average winds. Good indicator what the trades are doing. So pretty strong trades out of the East and the East Pacific. Same thing over the Central Pacific. Same over the West Pacific, the Kelvin wave generation area. But it is not the actual wind speeds that matter. Hard to believe. It is the anomalies, the difference from normal for this time of year. So looking at the trades in the East Pacific, well, we see the arrows coming out of the East, so they're a bit stronger than normal. That smells of the inactive phase of the MJO. Get over the Central Pacific, there's like no arrows at all, so everything's completely normal. Then we get into the West Pacific, yeah, arrows out of the East, so a little bit stronger. So kind of, if anything, maybe no MJO pattern at all. Let's keep digging. Here's the zonal wind anomaly forecast from the GFS model for the 2 weeks. Here's what's been happening. This is going back, I don't know, since mid-May, so about a month ago. Then here's the forecast going out 2 weeks. This is for the whole planet, though. Let's see if I can do this. There we go. 180, that's the date line. So this is, the Central to West Pacific. The far West Pacific starts at 135 east, so right about there. Okay. The main area we're interested in is from the far West Pacific to just east of the date line, right there. So this area, right about in there. The blues, easterly anomalies. That would be stronger than normal trades. Yellows and orange, westerly anomalies, weaker than normal trades. So right now, here you go, look at this. We're in a easterly anomaly pattern filling the entire West Pacific Ocean, I'll say. So that certainly looks like the inactive phase of the MJO. But the good news is, here we go, 5 days from now, westerly anomalies start encroaching, making it to the entrance to the West Pacific, and they make it the whole way to the date line on June 25th, so 10 days from now. They back off some. Earlier versions of this model had them continuing those. So seems like maybe that was the active phase. This is the inactive phase. Another active phase coming. Let's keep digging. The Madden-Julian Oscillation 15-day forecast looking at outgoing long-wave radiation. Basically just cloud cover. The active phase of the MJO, because it takes warm, moist air and lifts it aloft, that warm, moist air eventually hits the upper levels of the atmosphere where things are much colder. It will make clouds, and clouds would show up on this chart as blues. And that could be roughly construed to be the active phase of the MJO. Oranges and yellows would be falling air, the inactive phase of the MJO, dry air reaching the ocean surface. No clouds. But you see here, in South America, Central America, New Guinea, EQ, that's the equator, date line right there. So this is today, 5 days from now, 10 days from now, 15 days from now, basically 2 weeks out. This is a statistic model, so basically a dead neutral MJO pattern trending weekly active 2 weeks from now. Let's go see what the dynamic model says. Dynamic model, the GEFS model says, nope, just dead neutral the entire time. So what this is sort of saying is the MJO is going to have no real influence on the jet stream. And if it doesn't have an influence on the jet stream, it's not going to feed energy into the jet stream. The jet stream will not magically... My thesis is that the jet stream does not magically wake up all on its own without help from something. And most of the time, the MJO is the source of that energy. Not all the time, but 75% of the time. So if you see something like this, that means the MJO is not going to have a big influence. That means the odds for storm development, kind of, 50-50 at best. Let's keep digging. phase diagrams from the same two models, statistic model here, dynamic model here. What these charts do is basically just show you where the active phase is and how strong it is. Okay, how do you read the chart? Well, it plots where the active phase is. It moves from the Indian Ocean to the maritime continent, maybe like Bali, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. Round and round it goes. And you can see the past track of the MJO. This is the 12th, the 13th, the 14th of June. Right here, where the heavy dot is, where the active phase is. If the dot is within the circle, it's considered extremely weak. So the active phase looks like it's in the central Indian Ocean, very weak. And here's 1, 2, 3 forecast tracks. One has it making no headway and staying weak. The next one has it making it to the maritime continent and very weak. Another version says, oh, it's going to make it to the West Pacific, but still pretty weak. It's got to be pretty far outside the circle to really be doing something meaningful. That's the statistic model. Dynamic model has it meandering around and basically going nowhere for the next 2 weeks, locked over the Indian Ocean. And the Indian Ocean is pretty much sort of like where the active phase of the MJO starts its cycle, and then it moves around the planet, and then it limps back to the Indian Ocean, gets rejuvenated there, and then does another loop. This suggests it's not even going to try to make a loop. It's so weak, it's just going to stay there for the next 2 weeks. Welcome to summer. Here's another upper level model, basically similar to an outgoing long wave radiation forecast. The greens areas favorable for precipitation, more cloud cover. Oranges and reds, dry air, falling air, inactive phase of the MJO. This has the active phase of the MJO over the Indian Ocean, just like we saw, just where it's been for the past like 6 weeks. The model, this is a statistic model, says, okay, yeah, it's supposed to make its way across the Pacific until about the 5th of July, and then fade while it moves towards the Atlantic with the inactive phase setting up, but it hasn't budged in a month, so I don't know how believable any of that is. All right, so here's the CFS model, 850 millibar zonal wind anomaly chart. Dateline, 180, right up the middle of the chart. Far West Pacific starts 135 east, so right about there. This chart shows you the MJO, the black. When it's like tiny like this, it's super weak. So since March, the MJO has been pretty much non-existent. There's a weak active, weak inactive one. Here we are today. Is that an inactive? So little, it's basically non-consequential. What that really means is some other form of tropical wave activity is probably more dominant. Anyway, today, June 14th, actually yesterday, the blues, easterly anomalies, filling the Kelvin wave, filling basically the entire Equatorial Pacific. But give it about 2 days. Notice westerly anomalies start building to about 155, 160 east, so halfway to the date line. And then they are forecast to stay there the whole way through July 11th. So we're kind of in a funk for the moment. Here is where we had been, and we were actually getting good surf when these westerly anomalies were feeding the Jetstream just a couple days ago. We're in a funk, but it looks like things are going to wake up, at least according to this. Let's go look at one other model. Here is the CFS model going out not just a month, but 3 months. This is switched here. Past performances on the bottom, the forecast is on the top. All right, date line runs right up the middle. The blues are easterly anomalies, oranges and yellows westerly anomalies. Here's that same little stretch of blue easterly anomalies over the date line, over the date line region and the equator today. Starting tomorrow, maybe the day after, here come your westerly anomalies, at least neutral anomalies, if not westerly anomalies by later in the week, filling the entire Kelvin wave generation area, the entire West Pacific, and forecast building as we just continue for the next 3 months. This model has been rock solid about this. Yeah, it said it was originally supposed to transition from westerly anomalies to pretty much steady westerly anomalies back in March sometime, like back here. And you can see for sure the easterly anomalies, this is from La Nina too, have steadily gotten weaker, but now it's saying not even any more of those, just westerly anomalies moving forward. Let's overlay the MJO pattern. Now, interesting, it shows a weak inactive phase of the MJO over us right now. That explains why the Jetstream looks kind of split like it is. It explains why the storm track is displaced south over Antarctic ice. Explains why there's no real obvious swell producing storms on the chart. But give it about a week, and then now this is not an active phase, just like that is not an inactive phase. I mean, at least you got to have at least two contours to make what I'd call it a minimal active phase. So we're going to be in a weak pattern, but you have westerly anomalies forecast to be pushing over the West Pacific. And I think that's even more important than anything. That is like the deciding factor. So it seems like by a week from now, we should be in a much better place and getting steadily better. And then as we get into the beginning July, let's say about the 11th, a legitimate active phase pushes the whole way over the Pacific and fills the Pacific the whole way into fall with westerly anomalies building in strength. I mean, there is your window. So maybe we're in a little dead zone here, but somewhere, if this is even remotely correct by mid-July, maybe the southern hemi might wake up and we might do pretty good in terms of surf, which is kind of unusual. Normally you hit about the 4th of July, everything goes flat, and then you can't get to fall in somewhere in late August or September. It can't come soon enough. Maybe we'll get a surprise here. Hard to say. All right, let's overlay the low pass filter. This really tells the whole story here. All right, dotted contour is the high pressure bias. Call that the La Nina signature. We were in a Modoki La Nina all winter. Yeah, we had fun surf, nothing huge. And we actually have had a good run of southern hemi swell. Nothing big, but notice 1, 2, 3 contours. 2 of them are dead. The third one is, or the last one, if you will, is retreating to the east, and by mid-July is supposed to be east of the Kelvin wave generation area, exactly where we want to be. While the low pressure bias, remember I say it's over Indonesia, this is Indonesia right here. You notice it come about July, it starts easing off to the east into the West Pacific. I mean, it's right on it's like at 130 east, maybe even 135 today. This is past what's been in the past. Holding steady, but as you get a month from now, working its way into the West Pacific, that coupled with the westerly anomalies should really help take the focus, again, where the center of the low pressure bias is over Indonesia to over the West Pacific. That should do us pretty well come fall, and maybe even for later in the summer. We'll just have to keep our eyes on that. But this model, again, rock solid for quite a while now, looking pretty favorable. Now to the El Nino, La Nina portion of the discussion. Longer term outlook still. We're looking at subsurface ocean temperatures. This is across the Equatorial Pacific, from 2 south to 2 north, the whole way from Ecuador over to New Guinea and beyond. All right, 135 east is the far West Pacific. These little lines here with the X's, these are the anchor lines on the TAO buoys. The X's are the sensors. You take the sensor data and a model, fill in the gaps, and you get a profile of where the warm and cold temperature is. The stronger the trades are blowing from east to west, so the stronger the trades are, they take warm water, ball it all up into the West Pacific. But if the trades are steadily getting weaker, and that would be because pressure is lowering in the Pacific, and again, high pressure systems drive the trades, but if those high pressure systems are on average getting weaker, the trades will weaken, and then all of a sudden warm water will start sloshing to the east. All right, so we look at the isotherms here, the 29 degrees centigrade isotherm. Well, it was like way over here back in the spring. It's now at 175 west, so it has creeped a little bit to the west. The 28 degree isotherm last week was at 160 or maybe 157. It's now at 155, so definite westward movement here, suggesting the trades are slackening some. And then the 24 degree isotherm right where it was last week, about the same. But again, it is not the actual water temperatures that matters, it is the anomalies. Difference from normal for this time of year, we see positive anomalies the whole way across the thermocline across the entire Pacific Ocean. 0 to 1 degrees above normal. Now, that's not like cooking warm water, but it's just a move towards neutral, if not slightly warmer than normal temperatures. Notice no cooling really here at all in the upper thermocline either. This is a great sign. Let's go look at another chart. Same data, same place, but satellite data incorporated in it. Oranges and reds, warmer than normal temperatures. The date line is, right there. Warm water pushing across the date line into, well, to about almost a point south of California. You see other little pockets here. You see all this warm water down here. Also notice bits of warming starting to show in the upper thermocline too, suggesting that trades are just backing off some, so the sunlight can have a better chance of warming the ocean's surface and the wind isn't creating upwelling or turbulence. So in general, a turn towards a neutral pattern, it looks like. Let's go look at the satellite data. And I just zoomed in here. This is the equator right here. The date line is right here. That little squiggle there, that's the Galapagos Island. This is Ecuador here. There's South America, Central America, New Guinea there. Basically, there's no real change here. Positive anomalies, these are not positive temperature anomalies. The sphere of the ocean, a little bit higher than normal. Warm water at depth expands, displaces the ocean's surface up. Cold water at depth contracts, you get a divot on the ocean surface. So that's what this is measuring, the anomalous height of the ocean surface. So a little bit higher than normal here off the Galapagos. Not as high as it was, and if anything, it's decaying a little bit, but still right in the neutral range. And then warmer over here in the west, but not as warm as it was. We still have these little pockets of cooling north and south. That would be from stronger than normal trades, but the dividing line is really 5 degrees north, 5 degrees south. So the central equatorial Pacific, let's see if we can pull up the scale here. Well, 0 to -5. It's not above normal, just barely below normal, if not neutral. Upper ocean heat anomalies. All right, so this is just where in the upper 300 meters of the ocean is the water warmer or colder than normal. Okay, West Pacific here, East Pacific here. There's your cool pattern, your La Nina pattern that held into March of 2025, let's say midway through March. Notice the buildup of warm water here, and then there's this surge of warm water pushing east. Now notice the big warm pool kind of got tapped out by that push off to the east. So it's not like there's some big reservoir of warm water here, nothing to push us towards El Nino. But the surge of warm water, and we're talking just barely warm, up to maybe ½ degree above normal, suggests that we're at least moving towards a neutral ENSO pattern, neither El Nino nor La Nina. Sea surface temperature anomalies. Now, we were just talking about subsurface temperature. Ultimately, it's what's on the ocean surface that matters. And it is because if you have warmer than normal surface temperatures, that creates more evaporation, that creates lifting air, that lowers surface pressure. Likewise, if you have colder than normal water temperatures, that does not support evaporation. That creates high pressure above it, falling air, and that doesn't do anything to support storm development. All right, so South America, Central America, Australia, New Guinea, the equator right there, the date line right there. It's just 5 degrees north and south of the equator over the entire Pacific that really matter, but specifically in the Nino 3.4 region, the area from 120 west out to about 170 west right here. That's kind of the indicator for La Nina or El Nino. You see a little pocket of cooling here right at the edge of the Nino 3.4 area. But we have seen significant warming, not big warming. I mean, like down here at the bottom, like 1/4 degree. But it's now, at least according to this, filling the entire West Pacific the whole way to about 130 or 135 west. This is a steady, ongoing, but an improvement that has been happening over the past couple of weeks, suggesting, just like what we were talking about earlier, westerly anomalies are likely building over this area, or at least trades are getting weaker allowing the sun to bake the ocean surface and create warm water. However we get warm water, we'll take it. All right. Now, the one caveat here is this is using a 30-year collection of data. I forget what it was, from 1990 to 2020 or something like that. The planet has been warming steadily, so sort of what constitutes warm from an El Nino perspective is a little bit less defined than it used to be. Also notice here, the blue off of Africa here, stronger than normal trades in this area, suggesting, what do they call it? Like it's like a an Atlantic Nino. Anyway, not good for hurricane development, but that tends to be maybe something better for us over here in the Pacific. These tend to work sometimes in tandem, sometimes not. All right, let's keep going. Here's the 7-day trend. Our temperatures just warming or cooling over the past 7 days. You see steady warming over here out in the central Pacific. You see pockets of warming. There were more defined pockets of cooling here in this area last week, the week before that, but that seems to be fading. I mean, this is no big earth-shattering thing. Yeah, you see all this warming up here, but that is all very typical this time of year. It's the North Pacific is shutting down, the storm track's shutting down, the sun's beating on the ocean surface, so of course and the winds are getting calmer, so of course it's going to get warmer. But it is just the 5 degrees north and south of the equator that really matter. You see a generalized warming trend. Now let's contrast that. So just a minute ago I said, well, not the models, but the way we calculate what is warmer and colder than normal is it's not as solid as it used to be because the planet is steadily warming. So here's an alternate way of doing it. You just go and figure out what the average temperature of the ocean is across the entire planet, all the oceans, and then build a delta. How are temperatures warmer or colder compared to whatever that average is? You see the extent of the cooling here in the East Pacific is a bit broader than what we saw in the other charts. But even at that, on the equator right here, I'm looking over to about 135. Oh, this is about 150 west here. And the white is dead neutral. And even the expanse of that white is growing steadily over the equator. And again, it's just 5 degrees north and south of the equator. So even this chart, the way more conservative view suggests a return to neutral temperatures over a good portion of the equatorial Pacific. And then here are the sea surface temperature anomalies, different change, not over the past 7 days, but the past 15 days. And here on the equator, again, you can see much broader expanse of warming, pockets of warming. Yeah, there is cooling here, so there's still this kind of undefined pattern going on in the far East Pacific. But over in the bulk of the Pacific, temperatures are definitely warming. Here is the Nino 1.2 region sea surface temperature anomaly trend over, well, and this normally goes out like a month or 2 months or something like that, but there was a data corruption. Anyway, current value, we're 329 thousandths of a degree above normal. You see we kind of dipped down there for 1, 2, 3 days, just barely below neutral. But in general, temperatures have been up a third, fourth of a degree above normal. Looks like we've been through a little cold spurt. We're starting to rebuild. Now, out in the official El Nino monitoring region, again, this is not corrected data, or at least not heavily corrected data. In the Nino 3.4 region, current temperatures 193 thousandths of a degree below normal, 0.2 of a degree below normal. You can sort of if you put a line through this, you get the sense that temperatures are slowly in fits and starts warming, trying to get just to neutral. We're not trying to get to El Nino. We're not even trying to get warm. We're just trying to get to dead neutral. Now back to corrected data. This is weekly data for the week of June 4th. In the official El Nino monitoring region right here, it says temperatures exactly were at dead neutral, 0.0 degrees, neither cold nor warm. And we've been in some flavor of neutral, with half a degree plus or minus since February. So, but you can see steadily 0.1. There's a minus 0.2, but pretty much neutral. So we've talked about the MJO, we've talked about subsurface temperatures, we've talked about surface temperatures. What does the atmosphere on top of the ocean think is going on? We look at the difference in pressure between Darwin and Tahiti. Darwin, roughly over the Indian Ocean, maritime continent. Tahiti in the Pacific, equatorial central Pacific. When pressure is lower in Tahiti, the index goes negative. Hey, we're minus 3.16. When pressure is higher over Tahiti relative to normal, then the index goes positive. So you see, just looking back, we've been toggling, bouncing kind of all over the place since May 30th. The active or inactive phase of the MJO affects this index pretty markedly. This suggests a very weak MJO pattern. You see, though, back in May, we were positive, so this would be the inactive phase of the MJO, but before that, I don't know, it's kind of hanging around neutral. Let's look at the 30-day average. That takes the noise out of it, plus 4.18. So that's officially neutral, but it's still sort of on the La Nina side of the equation. Where were we a month ago? Minus 2.86. Now we're up to 4.80. Okay, and we go out 90 days. This is the El Nino La Nina indicator. Plus 3.94. Where were we a month ago? Plus 3.30, so dead neutral. Let's look at this data on a graph. Here you go. Here's the 30-day running average of the SOI. Neutral, according to this, plus 7 to minus 7. Today's value, right at about plus 7, according to this. This is, oh, that's back on the 13th, so that's a couple of days ago. Yeah, this chart sometimes has difficulty updating. But you get the general trend. The downward spikes are the active phase of the MJO. That suggests here that we are in the inactive phase, or maybe at the peak of it, and it is going to start fading. And with that, then, to the storm machine should theoretically wake up, give it about another week or so. One other long-term indicator, the outgoing long-wave radiation anomalies over time. Are the skies cloudier or drier or cloud-free as compared to normal? The date line runs right up the middle here. You can see plain as day, these positive anomalies, that's no clouds in the sky, that's high pressure falling air, that's your La Nina signal that we went in from like fall of last year until about middle of April. You see now dead neutral pattern over the date line. We want to see these blues starting to work their way into the West Pacific, and we think they will in about a month from now, as we start getting ready to get serious about looking at maybe what fall's going to do. And finally, the sea surface temperature anomaly forecast from the CFS version 2 model for the Nino 3.4 region, the official El Nino monitoring region. And we have some bad news here. The model, at least this version of the model, has temperatures dropping to about minus 0.8 of a degree as we get into fall, October, and November. I don't know that this is long enough of a dip to constitute La Nina or even a Madoki La Nina, but the model has been trending that way. 2 weeks ago, it was as neutral could be, and now a little bit at a time, it's getting more negative. Now let's go to look at the PDF corrected version of it. It has temperatures down to 0.65 a degree, and only for maybe a month and a half. So that wouldn't even be La Nina. That would just be a bias towards La Nina, but basically neutral. We'll have to see what all the other models say, though this model tends to do a pretty good job and gives you a pretty good early warning of what's to come. And it tends to be biased a little bit on the warm side, so we'll have to see on that. So for right now, kind of quiet pattern in the Pacific. No meaningful swells are pushing north, though there is a series of gales, one under New Zealand, one in the upper reaches of the central South Pacific over the next 2 to 3 days. Then maybe another one under New Zealand about a week out. The ice anomaly could be an issue, though. We'll have to see how that all plays out. Hopefully it will break up. Looking longer term, we are in, more than likely, even though the models don't say it, it feels like we're in some sort of a weak version of the inactive phase of the MJO. Give it about a week. That's all supposed to change. And we should be able to see that reflected in the wave models, maybe in next week's video. We should see a more robust sea height pattern under New Zealand and somewhere in the Central Pacific. That's just a guess. If west anomalies do build as forecast, or just east anomalies are suppressed, we should start seeing some activity. So I'm not going to get all despair and forlorn about the current surf situation. Every summer we have this, but it doesn't look like, at least for the moment, looking at the long-term indicators, and that's what we're kind of do, tease out beyond what the models are capable of seeing, using some inhuman intelligence, not artificial intelligence, to guess what is going to come. My sense is, I think we're going to do okay as we get, just get past about another week and the models wake up, and then we'll be back into some sort of a swell pattern. Beyond that, I'm still going to root for ENSO neutral for the coming fall and winter months. I'd like to hear what you have to, what you're thinking, and what indicators, what secret indicators you might have that give you sort of a farmer's almanac version of what you think the fall and winter is going to be like. But right now, ENSO neutral is my guess, which would be pretty much a normal precipitation outlook and a normal surf outlook as we get deeper into fall, especially as the last remaining remnants of Modoki La Nina get wiped out of the atmosphere, and the full planet really starts to fall into a ENSO neutral configuration. All right, that is our video for this week. If you enjoyed it, give us a thumbs up, please. The algorithm appreciates it. If you have not subscribed, I noticed the subscriber numbers are slowly inching up a little bit at a time. Thank you, I appreciate that. But please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. That'll get you all set up. You'll get notifications when the videos are posted. Comments or questions, always welcome. I want to hear your thoughts on things I learned from you all, and you give me ideas on what to put into the videos in the coming weeks. That's always welcome. And of course, if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. With that, we are done for this week. We are signing out. We will see you again next week, same time, same channel. Thanks so much for watching.